In today's math class video, I will give you an introduction to vectors and vector algebra. So firstly, we have to define what a vector is. A vector is an object that has both a magnitude and a direction. So geometrically, we can picture this vector as a directed line segment as presented here. And the length of this sector is called the magnitude. And there's an arrow over here which indicates the direction. The end of this vector is called the tail, and the head of its vector is called the head. Now, I will teach you some very basic operations on vectors. The first one is the addition of vectors. So, given two vectors, A and B, the sum of the two vectors is A plus B. And geometrically, you can illustrate it like this. Or if you use a column vector form, A plus B is equal to A1, A2 plus B1, B2, which is equal to A1 plus B1 and A2 plus B2. Now, the addition of vectors satisfies two very important properties. The first one is the commutative law, which states that the order of addition doesn't really matter. So, A plus B is equal to B plus A. Now, this law is also called the parallelogram law, so you can illustrate it like this. No matter how you add the two vectors together, whether it be A plus B or B plus A, they all end up in the same place. So that's why the commutative law works. The second one is the associative law, which states that the sum of the three vectors does not depend on which pair of vectors is added first. So you can have brackets A plus B plus C, and that's also equal to A plus brackets B plus C. Now I will explain vector subtraction. But before we define subtraction, we have to define the vector minus A, which is basically the opposite of A. So the vector minus A can be drawn like this. And the vector A can be drawn like this. Notice that the vector minus A is the same vector as A, with the same magnitude, but is pointed in the opposite direction. So we can define subtraction as addition with the opposite of a vector. So if we have B minus A is basically equal to B plus minus A. Now I will talk about scalar multiplication. Given we have a vector A, we can use a scalar, a number, which I now represent as lambda. I can write it as lambda A. Now, this scalar can be a positive number, which means that if A originally is a vector like this, then a positive lambda number can either stretch A if the lambda number is bigger than 1, or if the lambda number is smaller than 1 but bigger than 0, it can compress A to make it smaller. Now, if the lambda number is a negative number, let's go back to our A vector here, then it will reverse the direction of A, and depending on the size of the lambda number, if it's bigger than -1, then that means the A will go in the opposite direction, like this. But if lambda is between 0 and -1, then A will go in the opposite direction, but in a smaller magnitude, like this. So in general, we can write lambda A as this. Or if you use a column vector form, then it equals to this. You can also summarize both rules in the following rule. Linear combination of two vectors. Lambda A plus UB equals to lambda A1I plus A2J plus mu B1I plus B2J, which is equal to lambda A1 plus mu B1I plus brackets lambda A2 plus mu B2J. Or if you use the column vector, then lambda A plus mu B equals to lambda A1 A2 plus mu B1 B2, which is equal to lambda A1 plus mu B1, and then lambda A2 plus mu B2, written like this. So now that we have learned the basic operations of using vectors, which is addition, subtraction, and scalar multiplication, let's do some quick examples. So, for example, I have one vector here, A, which is equal to 3i minus 2j, and I also have vector B, which is equal to minus I plus 4j. So, I want you to find A plus B, 3a minus 2b, and 5a plus 4b. Now pause this video if you want to do it yourself first, and then re-click the video if you want to see my workings. So to solve question 1 here, you know that a is equal to 3i minus 2j and b is equal to minus I plus 4j. So using our addition rule, a plus b is equal to 3i minus 2j plus minus I plus 4j, which is equal to 3 minus 1i plus minus 2 plus 4j, which is equal to 2i plus 2j. Now, for the second question, notice that the 3 here is the scalar. So what you do is use the rule from the scalar multiplication. So you do 3a equals to 3 times a, which is 3i minus 2j, which is equal to 9i minus 6j. Now, notice the scalar here is a negative product, so you have to multiply b by negative 2. So what you have is minus 2 times b, which is minus I plus 4j, which is equal to 2i minus 8j. Now, question 4 here is a little bit tricky, as you need to use both addition rule and the scalar multiplication. So let's break it down. 5a is equal to 5 times 3i minus 2j. And then plus 4b, b is minus I plus 4j. And then you expand, which becomes 15i minus 10j minus 4i plus 16j. And in the end, you get 11i plus 6j.